Have you ever wondered why stars twinkle in the night sky? They seem to be just tiny dots of light flickering in the vast cosmic canvas. But what if I told you each of these twinkling lights is a story of cosmic proportions, a tale of birth, life and death? Yes, stars aren't just distant points of light. They are celestial bodies with a life cycle that's as complex and intriguing as life on Earth. Stars are born, they live, and eventually they die. And each stage of a star's life is a spectacle of cosmic proportions, a testament to the grandeur of the universe. From the fiery birth in a nebulous cloud to the serene luminosity of the main sequence and the explosive end in a supernova or a quiet fade into a white dwarf, each star has a unique journey. Join us as we delve into the fascinating journey of a star, from its birth to its inevitable end. It all begins in a nebula, a vast cloud of dust and gas in space. Now picture this immense expanse of cosmic material, seemingly idle, yet teeming with potential. It's like the universe's very own nursery where stars are born. Gravity, that ever-present force, begins to pull at the dust and gas in the nebula, drawing them together into a clump. This clump, over time, grows denser and denser, forming what we call a protostar. It's like a star in its embryonic stage, not quite a star yet, but well on its way. Now, this protostar isn't just sitting quietly, oh no, it's growing. As more and more material is drawn into it, the protostar's mass increases. And with mass comes gravity. The greater the gravity, the more material it attracts, and the cycle continues. But it's not just the mass that's increasing. As the protostar grows, pressure and temperature at its core also rise. And it's here in this high-pressure, high-temperature core that something truly remarkable happens. When the core temperature reaches a staggering 10 million degrees, protons begin to come together in a process known as nuclear fusion. This is the same process that powers our Sun and every other star in the universe. It's the moment when hydrogen atoms fuse together to form helium, releasing an incredible amount of energy in the process. This energy pushes outwards, counterbalancing the inward pull of gravity. A delicate yet powerful balance is struck, and the protostar stops collapsing under its own weight. It's at this point, with nuclear fusion igniting its core, that the protostar transitions to a full-fledged star. And so, amidst the cosmic dust and gas, a star is born. It's a process that takes millions of years, a blink of an eye in cosmic terms, but the result is a glowing beacon of light and energy, a new addition to the universe's stellar family. The star, now fully formed, enters a period of stability known as the main sequence. This phase, often considered the star's adult life, is the longest, spanning millions to billions of years. It's a time of balance and tranquility, a cosmic ballet of forces where gravity and radiation pressure dance in perfect harmony. During this stage, the star's core is a nuclear furnace where the process of nuclear fusion occurs. Here, hydrogen atoms are squeezed under immense pressure and heat, coalescing to form helium. This fusion process releases an enormous amount of energy, which we perceive as light and heat. This light, this radiant energy, is what makes our own star, the Sun, shine so brightly in our sky. It's what warms our planet, allowing life to thrive. Imagine, if you will, the sheer power and intensity of billions of these nuclear reactions happening every second, converting 4 million tons of matter into pure energy. Now, the length of the main sequence stage is not the same for all stars. It depends on the star's mass. The larger the star, the more hydrogen it has to burn, but paradoxically, it burns through its fuel much faster. So, while a massive star may shine brighter, it leads a shorter life. On the other hand, smaller stars, like red dwarfs, burn their fuel more slowly and can remain in the main sequence for hundreds of billions of years, far longer than the current age of the universe. So the main sequence stage is a star's prime time, its moment in the celestial spotlight. It's a period of balance and stability, where the star radiates with constant brightness, fueled by the conversion of hydrogen into helium. Like a heart beating in the cosmic body, the star continues to burn and shine. It pulses with energy, radiating light across the vast expanse of space, a beacon amidst the cosmic dark, a testament to the power and beauty of the universe. Every star, no matter how bright, must face its end. In the grand cosmic ballet, Stars are the prima donnas, lighting up the universe with their radiant glow. But like all performers, their time in the spotlight doesn't last forever. When a star has burned through its supply of hydrogen, the fuel that sustains its luminosity, it's time for the final act to begin. The star's core, now predominantly helium, contracts under the force of gravity, heating up to temperatures that spark the fusion of helium into carbon and oxygen. This new fusion process releases even more energy, causing the outer layers of the star to expand and cool down. This stage of a star's life is called the red giant phase, named for its swollen size and warm, rosy hue. But the star's struggle against gravity doesn't end there. Once the helium in the core is depleted, the star contracts again, igniting a cycle of fusion and expansion with progressively heavier elements. This process continues until the core starts to fuse iron, a step that doesn't release energy but instead absorbs it. This iron core is the star's death knell. Without the energy to counteract gravity, the core collapses under its own weight in a fraction of a second, resulting in a supernova explosion. The star's outer layers are violently expelled into space, creating a brilliant spectacle that can outshine entire galaxies. What remains of the star after this cataclysmic event depends on its initial mass. Stars like our Sun leave behind a dense, hot core called a white dwarf, while more massive stars collapse into an even denser neutron star, or an infinitely dense point known as a black hole. In each case, the star's death is not a quiet fade into the night, but a dramatic fiery finale that sends its enriched ashes out into the universe, seeding the cosmos with the elements necessary for new stars, planets, and even life to form. In its death, the star leaves behind a testament to its once magnificent existence. From birth to death, the life of a star is a cosmic journey that spans millions to billions of years. This journey begins in nebulae, vast clouds of dust and gas where stars are born. The pressure and heat from gravity pull together these particles, leading to the formation of a young star, or protostar. The star then enters the main sequence phase, its long, stable period of existence, where it shines bright, fueled by nuclear fusion at its core. This phase can last for billions of years, a testament to the star's resilience in the face of cosmic time. However, even stars must meet their end. Depending on their mass, they either explode into supernovae, leaving behind a neutron star or black hole, or swell into red giants before shedding their outer layers, leaving a white dwarf. Next time you look up at the night sky, remember, each twinkling light is a star, living out its cosmic journey just like you and me.